The -2 locomotive high voltage cabinet trainer functions electrically as an operating locomotive and provides hands-on access to the locomotive control system electrical equipment. The physical locomotive equipment includes a high voltage cabinet, an AC cabinet, and a control stand. All simulated locomotive devices and non-locomotive equipment are installed in a separate instrument control stand. The high voltage or HVC cabinet includes the same switchgear, control modules, relays, and other equipment as used on a physical locomotive. There are different styles of HVC cabinets, and the location of certain equipment will vary from one style of cabinet to another. HVC cabinets also vary in size. For example, some cabinets built for export are not as tall as the cabinets installed on locomotives built for the US domestic market. The AC cabinet includes the fan contactors, the fan controller, and other equipment such as the load regulator and the fuel prime engine start switch. The control stand includes the throttle, reverser, dynamic brake, and other devices such as the headlight and sanding switches. The instrument control stand includes multiple AC and DC power supplies, control electronics, and a software control program to simulate locomotive devices such as the main generator, traction motors, braking grids, etc. The HVC trainer DC bus volts are scaled by 10:1 and the DC amps are scaled by 1000:1. This is necessary in terms of the practical use of equipment and personal safety. When simulator power supplies output 50 volts at 1 amp, other simulator equipment adjusts the electrical feedback signals and the locomotive control system responds as if the simulator output 500 volts at 1000 amps. The locomotive functions are performed in simulated time, not real time, and the operations are performed using incremental steps. For example, the traction motor power increase reaction takes a longer time on the HVC trainer, but the final steady-state operating point will be the same as a physical locomotive. The software control program provides a user interface to display the locomotive operating values and to receive user input to set up specific locomotive operating conditions. The display is organized into groups of parameters to describe locomotive devices such as the engine, the main generator, traction motors, and the mode of operation. Some example user input parameters are engine temperature and the locomotive track speed. A separate display window indicates the on-off state of locomotive devices such as the starting motors and headlights. The locomotive control system will respond as appropriate to activate these indicators instead of the physical locomotive devices. To help compare the HVC trainer to a physical locomotive, a few common operations are demonstrated in the following video. Engine startup. Turn the fuel prime engine start switch and the control software user interface displays the engine start sequence. Traction motor power. Set the direction handle to forward or reverse. Set the engine power notch position. Set the track speed limit with the control software user interface, and the locomotive control system responds by applying power to the simulated traction motor loads. The control stand amp meter displays the traction motor current. Reduce throttle handle notch position and the control system decreases power application to the traction motors. Dynamic braking. Move the dynamic brake handle to set up the position and the switchgear operates to configure dynamic braking mode. Move the brake handle to increase braking effort, and the control system responds by applying power to the simulated braking grids instead of the physical locomotive braking grids. Use the locomotive track speed user input to reduce the simulated locomotive speed as a natural dynamic braking response. The locomotive control system reacts to the reduced speed by activating the extended range dynamic braking equipment. Decrease braking effort and the locomotive control system will reduce dynamic braking power. Load regulator. The software control program and an electric motor operate the load regulator to simulate the performance of the diesel engine and the action of the hydraulic vane motor. The locomotive load test function operates normally. The control software user interface displays the engine, main generator and the braking grids performance values as the test proceeds. Traction motor cutout. Turn the traction motor cutout switch to operate the motor switchgear in the same manner as a physical locomotive. Engine temperature. Change the engine temperature input value with the control software user interface to simulate a temperature change in the diesel engine. The fan contactors are installed in the AC cabinet and the locomotive fan controller system responds by cycling the fan contactors on or off as necessary. The HVC trainer provides a complete locomotive control system and can be used for instruction or training exercises instead of a physical locomotive. To help with any electrical alterations a training instructor may use to teach electrical troubleshooting techniques, special switches are installed on the -2 control modules to help create the effect of some typical fault conditions. Documentation describes the switch function and fault effect for each of the -2 control modules. The trainer documentation includes a locomotive-style wiring diagram with markups to describe equipment and wiring that is different from a physical locomotive. This example indicates the engine coolant sensor does not exist and the sensor wiring connects to the simulator control equipment. In this example, the governor valves do not exist, and again, the wiring connects to the simulator control equipment. Other forms of documentation include a function block diagram and a simulator control equipment wiring diagram. This presentation is a brief sample of the HVC trainer capabilities. The trainer is a complete locomotive control system and simulates other functions such as wheel slip, wheel slide. At Elcon Inc., we welcome your questions and comments. Please contact us for more details or to discuss any specific requirements. Thank you for watching. We appreciate your business.